I'm Muskan and I'm working as SD at Juspay. So I work in payment page team, and I'll be talking today about functional programming in front end. What is the use case of it? What are the benefits of it? And why basically straight from college you should be understanding why functional programming is very important for a front end engineer. So functional programming has recently become a big thing in front-end development, but why so? Is it an example of hype-driven development, or are there actually reasonable arguments to use it? While I try to answer that, I'll also intend to explain you basically what is functional programming, what are the use cases, like how it can be used in front end, and most important of it is why, right? Why as a front end engineer you should be knowing about functional programming and using it. So let's start with a real-time case study. So at Juspay, we use functional programming extensively and exclusively for all our front-end SDKs. And this has helped us a lot. So at Juspay, all our SDKs are basically, transactional apps. So in general, transactional apps are nothing but simple conversational flow between the user and the system, and they can be written pretty simply using conversation like UX, DXL, and CSV semantics. But despite this being the important problem to simplify, we found out that the current frameworks complicate the building and the maintenance of the transactional processes, so which requires a heavy investment in the engineering efforts, and development process is also not very pleasant, and it leaves a very little room for creative freedom. So at Juspay, we saw no reason for this to be the case. So we decided to set out and create our own framework, basically to dramatically lower the barriers of entry for quickly building our solutions to typical real world applications. Being strong believers in functional programming paradigm, we abstracted out all the parts of an app into extremely composable Lego blocks and pure functions, right? Which helped us a lot. So this helped us achieve supporting multiple SDKs, which are not just related to entire payments, but also very specific. For example, UPI apps and all. And we also managed to develop single SDKs to power the cross-platform apps. So basically, be it a hybrid system, be it an iOS system, be it a web system, we have a single code base. We have a single code base to support multiple SDKs, and for that, this was possible only because we were using functional programming. This left us a very strong room for creative freedom, and majority of the time, we are getting able to get the 10x output with a very minimal effort. So, but the question is how functional programming benefits a general software engineer, general front-end engineer, right? So I'll be basically talking about that, and I do have some points in favor of FP while writing front-end as opposed to your traditional OOPR methods, and I'll be going them over one by one. So first is JavaScript as OOPR, right? So JavaScript as OOPR, if you have used JavaScript, you will understand the pain of this tweet, right? Because majority of open source libraries which are available in OOPR structure for JS, they become a pain point at one point or the other, because some weird behavior happens at the runtime. There are some trivial issues, but they are very easy to debug because they are going in some very weird corner cases, like as this author is saying, right? That he can never be sure what this refers to. It's very hard to identify the object that is actually being referred to. But basically, what is the cause of this conflict? Why JS is very difficult to use as OOPR, right? So this is JavaScript as OOPR. JavaScript as object-oriented programming used to be very weird in the past. This is one of the reasons why functional programming on front end might have gained such popularity, rather than the argument to use functional programming paradigm. So although it's worth mentioning this weirdness in name of better context, a little bit of history here. So in early days, object-oriented programming in JavaScript used to be slightly weird. It was possible to use this kind of programming, basically write OOPR with JavaScript. However, it was not close to what you have seen in your other object-oriented languages like Java or C++ or any other object-oriented programming language. There were some issues with functional programming languages. So just take a look at this example. This code doesn't look like a object-oriented code that you know from Java or from like C++ or any of your object-oriented language. It is due to the fact that JavaScript offered a prototype-based inheritance in contrast to the class-based one, which is the basically most popular approach that other programming languages take, right? So why JavaScript took this way? In the 90s, we had less powerful computers and obviously less sophisticated browsers. So when JavaScript was invented, prototype-based inheritance had been chosen. It was easier to create an interpreter for it and preserve the OOPR features at the same time. So I'm guessing probably that's the reason. What's more is it took 20 years before ECMAScript 6 with final semantics for classes were introduced. Earlier prototypes were used, and some of them also made use of this JavaScript as a functional programming language, right? So these are truly powerful concepts and were available a long time back, long before ES6 classes came into picture. Hence, it might be the reason why not all people adopted ES6 classes syntax in their code base. I mean, of course, classes have become popular in React and Angular based apps. Although if you're considering the single standalone micro libraries for which like NPM is famous for, classes keyword is still pretty rare and functional approach beats it. So even though JS exists as OOPR, I am guessing JS was intended to be a functional programming language from the beginning. Okay, so to those of you who are like, new to functional programming, I'll give you a little context of what are pure and impure functions. So in functional programming, there is a concept of pure function. Pure function is nothing but it's like, for a given set of arguments, the output is always going to be the same. So suppose if you pass A and B to a function, the output is always going to be C. If you pass C and D, the output, if once is D, it's always going to be D. While it also ensures that it has no other side effects, right? Like it doesn't modify a global variable, or it doesn't like, do any IO operation as such or anything. So this slide is basically an example of your pure function and your impure function. So first is basically an impure function, which is modifying a global variable result array. And second is a pure function. So you may wonder why, like, why you should be using pure functions. Pure function could maybe like, less optimized. Because if you take an example of like, let's say you have to add a value to an array. And if you're writing a pure function, you may think that like, you may have to create a new array and then append the value at the end. And like, the CPU has to process the entire array, create a new array, and then append the value at the end. But in reality, FP languages are smarter than that. The fact that programs cannot perform some stuff directly, it limits the programmer, yes. But on the other hand, it guarantees a very important thing, and which is program won't do anything fancy at the runtime. So every front-end engineer's nightmare is basically like, runtime debugging. The program is doing something weird in the runtime and you're not able to debug. And pure functions, on the other hand, ensures that the programs are predictable, as well as like, they also help in optimization. So one of the optimization technique that I think I can discuss is memoization. So what is memoization? Basically, memoization is when a function is called with a specific argument for the first time, you cache the result and you return the result. And when the function with the same argument is called again, you simply return the cached result. You don't just go about processing the entire data once again. So this is a fairly simple rule to implement, right? This is very easy to implement in JavaScript or any language as such. And it can be really useful in cases when the time cost of calling a function is high, but you have to call the function very frequently. But for memoization, there is only one requirement. Function that you want to memoize are supposed to be pure, because otherwise it is not guaranteed that the remembered result is the correct one. And the value that you are getting after like, calling the function is correct or not. So hence, like scope to pure functions, and pure functions in turn is a very strong and important principle of functional programming. So if you are using functional programming in front end, pure functions are just an additional benefit that you get on its own. Next point in favor of functional programming is declarative style of writing code. Declarative style is very readable when describing visual aspects. So when it comes to visual aspects, declarative style is desirable on the front end side. HTML, CSS, SVG are languages which describe the structure and appearance of the elements rendered on the browser. So naturally, when it comes to JavaScript frameworks, this approach is also popular. When you learn a functional programming language, it can be reused also for the visual aspects of your program, in contrast to learning another separate syntax for templating. In React, for example, thanks to the virtual DOM system, we can easily apply map, filter, reduce functions, which are well known in functional programming, and they can be applied to component rendering definition directly. So basically, declarative style is very much readable, and it basically doesn't make your code readable only, but it also in turn reduces the bugs that that could be there because of the complex structure that you may have in your front end requirements. So every JavaScript developer these days has to deal with the asynchronous nature of JavaScript, right? When Node.js came out, one of the anti-patterns that became very famous was callback hell. I'm not sure if you guys have faced it, but if you're making any network call in JS directly, you will understand the pain, right? You have to write promises and promises within promises and so on, right? And this thing is particularly difficult for junior devs. Like simple task, if you have to post some data through Ajax to endpoint X, and let's say on success you get new data and you use that new data to send to endpoint Y, or let's say you have 3 different endpoints XYZ and you wait for response from all XYZ and then you combine the data and do something with it. This is very difficult to do for the new developers because of the asynchronous nature of the JavaScript. But there are promises to the rescue. So basically, promise is a well-known pattern that makes it easier to control the asynchronous code and can make it more readable, in contrast to typical callbacks. There are many tutorials available about it, and probably you guys also know about it. There are also other patterns to deal with asynchrony in JavaScript, that's like async await and all. But there is one thing that is worth mentioning in functional programming context. Promises have so much in common with monad, which is a functional programming concept. So the thing is that promise is really similar pattern to monad, as monad can help you with wrapping a value to some context and can add specific behavior to operations that are applicable to them. Promises will help you wrapping the future value which will come from the asynchronous operation, and then they add specific behavior which enables you to chain the operation that are to be performed next through simple chaining of dot then, right? So consequently, we can benefit from functional programming on front end whilst day-to-day programming. Even though at first it offers features which may look very complex and it may look like a mathematical terminologies, but in turn optimizations and ease of writing code is very heavy when you're using functional programming on front end. Another good example where pure function can shine is in terms of optimization of virtual DOM. For instance, Elm is a programming language which is functional, and you can optimize re-rendering of some DOM elements by decorating the function that produces a lot of DOM elements on each. So in conclusion, basically we can say that functional programming is not only a hype, especially in front end. The concept that it introduces have already become handy in front end development practices. It proved that object-oriented programming is not the only way and definitely not the better way of composing maintainable apps. Functional programming can help you deal with a large number of various types of data which your app state might consist of. It can make some contribution to TDD by simplifying or eliminating mocking altogether. And even if an immutable approach of data may look wasteful for memory resources and performance at first glance, it opens the door that enables optimization just at another level of abstraction. Perhaps you use some patterns already because this is being told by the framework that you are using, but you have no idea that this is based on a functional programming concept. I could go on and on about the reasons in favor of functional programming on front end, but I hope the examples that I've chosen have convinced you to write your front end code in functional way if you're not doing it willfully already. Especially we are living in an era where functional programming is almost impossible to avoid. So I'll just end my presentation on this note, and I wish you all good luck, and I hope that in hackathon you make use of functional programming and while creating your beautiful front end applications.
Yes. So my topic will be why FP for backend, specifically for backend. Why? So when I started with Juspay, right? It has been 4 years. I have been started working with Juspay, and there was no mention of FP when I started off. Then what was exactly in FP that got us fascinated in first place to move towards FP and leave behind all the details and all the hard work that we have done with while developing our code base, our previous code base. So let's start with what exactly FP is at front end. Just a sec. Yeah. So even before I started learning functional programming, there were a lot of discussions going around in my office regarding should we go around FP, should we not, what can be the repercussions, what can be the usefulness, and there was definitely a lot of buzzwords around it. For example, it is a pure functional programming, higher order functions, monads, and of course in center there was lambda calculus. Now, as soon as I heard about lambda calculus, because I already have a relation with lambda calculus, I have learned lambda calculus and spent a lot of time on it. It got me to read about functional programming in more deeper sense. Now, in at the simplest form, what exactly functional programming is? It is nothing more than a style of writing your code base. Right now, whatever snippet you are writing, there is of course a way of writing that in a functional programming way. The only method that it uses is to pass the arguments and to apply those arguments to the passed function. That is it. It's as simple as it can be. There are different programming paradigms to it. For example, we use Haskell here at Juspay, and Haskell is a purely functional language. There can be another languages which can support multiple paradigms. For example, JavaScript has a support from object-oriented as well as for functional paradigm. Recently, Java and Scala also have introduced functional support for their languages. What exactly is a blub paradox? So blub paradox means that whenever we place a language on the scale of left to right, whenever we move to right, it enables to look at languages which have more features, which are more optimized, which are more efficient. But those might sound weird to us. For example, right now, functional programming might be sounding weird for all of you because you don't know it yet. But once you move to your right, you will see what were the shortcomings in other language, another paradigms, and why we should use FP. And whenever you move to your left, you will see you that you are these are the languages that you are aware of, that you know very well, and you know the shortcomings as well. As we already discussed, that Haskell is a purely functional language, and functional language is nothing other than applying the passed arguments to the function. It's very similar to mathematics, whatever we do in maths. So we always use this mathematics approach of passing arguments in a parenthesis and everything. Here, instead of parenthesis, we use space. Space is the thing that defines the precedence of past arguments. So if you love mathematics, you are ought to love Haskell as well. As we discussed, functional programming is just another style of writing, but just another style of writing can't be so powerful that it changes our whole perspective to our code, to our payments, and toward coding and toward building up our stack. Then what exactly is it introducing us to? What more is it in it, FP? So there is another powerful concept called pure functions. What exactly are pure functions now? So pure functions are something, as Muskan also discussed, pure functions are something which are completely based on your past input. Whatever input you might give, it will just consume those input, do the computation and returns the output. It doesn't have any effect on the outer world. By outer word here, I means everything, anything that is not a part of your given function. So if you are doing a DB call inside a function, it means it is impacting the DB. It might be creating a record, it might be updating a record, but it is not pure anymore. It has a side effect. So pure function is basically which is just based on its input. For example, here, if you see the snippet on the topper portion, it has a Haskell code where it is taking two inputs, running some computation. Here, the computation is addition, of course, and then returning the output. But if you see the snippet of JavaScript, what exactly is happening? It is running the same computation, but it is updating a global variable as well. and that global variable has existence irrespective of this given function. So this means it's not a pure function, it can access outer variables as well. By this brief introduction of FP, we are able to derive few very useful tricks that FP provides us. For example, it will lead to very fewer bugs because we are explicitly very sure what are the input types that we are passing to the function and what exactly can output be. Another very good effect of FP is the code becomes very much manageable because you can see the readability increases if you use FP. It's as simple as you writing in English, you are giving a command to computer, it's just build my screen, as simple as that. Another thing is reusability. So when you actually at a college level, you might not understand the very effect of reusability, but when you move to a tech world, you will understand how important it is actually to make your code not only work but make it manageable as well as reusable. Reusability is basically dependent on that if your function is not creating any impact that is not required, or any impact which is other than on its past inputs, it will not be reusable anymore. For example, I am creating a function and it is used in flow 1. I am passing two parameters, it's doing some computation and returning me an output. But if I want to use the same function in another flow, how can I use it? I can only use it whenever I am sure that it will only take the inputs, do the same kind of computation that I am expecting, and then return a value. Another great part about FP is that it's mathematically proven. Anything that is mathematically proven can't go wrong. We all know about that. Yeah. Next thing, we are discussing exactly why FP in backend. But before that, let me tell you what exactly backend is. So if you ask me, I will tell you a short snippet of all these 5 features that include backend. Whenever you hit the server with the request, that is called a API call. And that API call might be fetching data from some data storage. It can be Postgres, it can be DB, or it can be Redis as well. It can be anything, doing some data transformations from one type to another, anything like that. It might include third party DB calls. Third party means it can talk to some another service which might be internal, which might be external. And here in case of UPI, for example, we talk to NPCI. NPCI is a common thing for all the payments, for all the UPI payments, and that is a third party for us. And then finally, it returns the data to our consumer. So now we know what exactly backend is, but we are now discussing what exactly are the challenges faced by that backend. So at top, of course, there are logical errors. Why logical errors? Because we all are humans. We all make mistakes. Despite all the regression testing, despite all the test cases that you write, there can some bugs that can escape the testing and make a way to your production code. There can be the way. And then there is latency and performance. What exactly latency is? Latency is the time period from the time that you hit a request, that you click anything that makes a call to backend and make the flow start moving, till the time you get a response back. For example, in case of payments, if you see, whenever you click on send money, and till the point you get to know that your transaction was successful or not successful, till that point the time period is called latency. So now we all don't want to wait for like 1 minute to just know what is the status of our transaction. We want it to be done as sooner as possible, in seconds, in milliseconds, whatever it takes, but we want it faster than ever. So how FP is helping us in solving all those challenges that are faced by everyone everywhere, and everyone is trying their best to solve these challenges. Here I'm showing you an example of the logical error thing. Here, using the same example, if we write a function, give them to output, here we have writing that the function name is addition. So if you hear the function name is addition, you will obviously expect the output to be an integer only. But voila, you are not getting the output of an integer, you are getting the output of a string. And surprisingly, this code will run fine. This code will compile very finely, very smoothly in your compiler. it will create an impact when you actually want to do some transaction and want to use the output. At that time you are expecting a int, but you are getting a string, which will eventually affect your live traffic and create a downtime. Another thing was our performance and latencies. So here I'm sharing some data with you guys to see that how our JavaScript code was serving and how our HS code is serving. Here HS means Haskell code. So there is a API called get session token for which you have to take a token for every transaction that we do. Here, from JavaScript, when we were doing the similar API, it was taking around 500 milliseconds for that API to work. But when we move that same API, same logic, and same database, we haven't changed the infra part at all, and we moved that same thing to our Haskell code base, it reduced to less than 200 milliseconds. So you can imagine the level of impact it will create with even better infra and with even better resources. Yeah. Moving forward, we know that it creates an impact on our performance, our latency, but how exactly will it create? We are not changing anything, we are not changing the logic also, but how will it create? So how it will create, the answer goes to another feature of functional programming, means that the feature is called laziness. The laziness means the Haskell is a lazy language. Where, what exactly do I mean by lazy language? Any lazy language will only do the computation unless it is very necessary. It's absolutely necessary. So whenever you write any code, it is not executed. You have just written it and it's stored in the memory, but it's not executed unless you uses its output. Here is an example for that. Here I have defined a variable called C. C has a value of A and B's addition. But if you see, okay, variable C is only being used if the if condition is satisfied. If it goes into else condition, we are not using the C variable anywhere. So that is how it saves on the computation, it saves on the RAM, and then hence increasing your performance as well. Another great benefit of this is it makes our regression testing very easy. How it can do that? Because we are explicitly defining our input type and output types, we exactly know what range can be input and output be in. So we actually define the ranges and pass all the variables in those ranges, all the data that can be present in those range, and see what exactly output is coming. That's how we are, it gives us immense confidence also when we go with this code base, with this testing code base in our production, because we know we have tested each and every possible case. Another thing, right, we discussed that FP is that pure function is something which doesn't create an impact on the outer world. But if we talk about backend, what exactly is impact on the outer world? Is it means like whenever we are doing a transaction, whenever we are checking our balance, we are making money move from one place to another, it actually makes an impact on the outer world. Something is happening in the outer world. So whenever anything like that happens, it is called a side effect. Side effect will creates a DB entry that was never there before. So that is the new state introduced. That's why it's called a side effect. And any function having that side effect is called impure function. Another thing is, another feature of actually functional programming is that it is immutable. What exactly is immutable? Immutable is something that you cannot change. For example, in your languages, you might be using constants. Constants is something that you can't reassign value to. So here, instead of using variables, we use constants. Even if you define a variable, it actually behaves like constant. So if you write a code, see, there is no possibility of writing code without variables, but the only difference is that those variables are not being treated as variables. You can't keep reassigning values to the same variable. It behaves as a constant only. If you have defined c is equal to 5, you cannot on next lines declare that c is equal to 10. You cannot do that. It's immutable, it will not change. And that actually creates an impact on how we debug our problems. Whenever we want to see that what is the value of this problem, of this variable, of this constant, we are very sure that it is not changing over time. It is not changing how we go towards the flow. We know that its value is this, and it will be the same throughout the flow, which helps a lot in debugging the live problems. So, just to conclude what exactly functional programming is, it is just a way which removes a whole class of bugs for me. Even at the development state itself, I don't even have to test because the compiler is so strict that it enforces me to write the correct code. It will not compile if I am not writing the correct code, if I am not returning the right values. That is the main part here. So, a whole class, a whole set of bugs and errors that can happen in production are removed at development level itself. That's why it is impacting our services, it is impacting our downtime, and as well as performance also. So another feature, another exciting feature of functional programming can be DSLs. What exactly DSL is? DSL is a domain specific language. Now you always can create your specific language, which are very frequently used by your company or by your peer group. For example, here in FP, we have created our own domain specific language, which is called Presto at our end. Presto is basically a payment supporting language, and it can be used with various products. For example, we do a various types of transactions. It can vary from card details, from to UPI transactions to net banking and all of those things. But at the very core, what exactly is happening? You are making money move from one place to another. It can be from between you and your friend, it can be between you and Swiggy, it can be between you and Amazon, right, to any merchant you can have. But exactly what is happening is you are making money from one account to another, and that's all. And that is what we call as domain specific language. We have written functions which takes, let's say, in account of two different users, it can be credit account and debit account, and then make money move. That is it. That is the whole payment system, right? And this using DSLs also enable us to move 10x efficient. And because we are moving 10x efficient, we are able to focus on bigger problems. What exactly is still the roadblocker in making payments one click, making payments much more easier in India, and hopefully one day throughout the world as well. I have picked out some articles for you guys. If you are interested in functional programming, if you just got the curiosity out of these sessions that what is functional programming and you want to try those out, you can give these articles a read. Thank you so much, everyone.
Thank you so much, Manzil, for joining us today. I'd like to request all the attendees, if you have any queries related to Juspay, you can drop them in the Discord channel, and the team of Juspay would be happy to help you out.
Yeah, sure. Yes.